Hello and welcome to another GCSE revision video, and in this video we're going to be looking at scaling. In mathematics, if we keep the shape the same but increase or decrease its size, we call it scaling. The scale factor is the number we multiply each length by to get the end result. If the scale factor is less than 1, then the final object is smaller. If the scale factor is more than 1, then the final object is bigger. Sometimes on drawings, especially on maps, you will be given your scale factor either as a ratio, like 1 to 500. That means for every 1 unit on the map, the real life equivalent is 500. In other words, the real shape or the real life equivalent is 500 times bigger than the model or the map or the drawing or whatever. Sometimes you will get a distance just listed on the map, just a line with a start point and an end point, and you'll be told that that distance, the real life equivalent of that distance, so this distance on the map is equal to 100 miles in real life. Or you might be told something like 1 centimetre is equivalent to 1 kilometre. So that means 1 centimetre on the drawing or the map or the scale model is equivalent to 1 kilometre in real life. So one of those sort of methods will be used to describe the scale factor. Okay, once again you get to behold the awesome majesty that is my artistic talent. Alright, in this question we're told, here is a rough sketch, and I emphasise the word rough, of the tiny model house hanging from my charm bracelet with measurements. I should at this point for clarity say that I have no charm bracelet. This is purely hypothetical and this is purely a mathematical exercise. Any similarity to the real world is purely coincidental. If I said the charm bracelet house was a 1 to 500 scale replica of my home, then how tall would my home be in reality? And when I say reality, I mean the hypothetical reality of this mathematical exercise. Alright, so in this rough sketch of the charm bracelet house, the height of the walls is 1 centimetre and the height of the roof is half a centimetre. So the whole building is the model is 1.5 centimetres tall. Now this 1.5 centimetres charm bracelet house is a scale model of the real house, and the scale is 1 to 500. So that means 1 centimetre is 500 centimetres. So 1.5 centimetres is 1.5 times 500, and all that is centimetres, which is equal to, well, 1 times 500 is 500, and half of 500 is 250, and 500 plus 250 is 750. So my house is 750 centimetres, and those aren't really good units to use for such a large building, so we should actually really show that in metres. So that's 7.5 metres, because 100 centimetres is 1 metre. So the real house is 7.5 metres tall. Okay, let's try another example. Well, it seems I've been invited to a party at somebody called Jim's house. And apparently, according to this crudely written map, it's not very far from the school. In fact, it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 little squares due north. Well, that's straightforward. I think I would like to go. Maybe I'll just take a little walk. But wait, is actually drawn that one of those squares is 1 centimetre. I'll get my little ruler out and check, and yes indeed, each of those squares is 1 centimetre. Now why would he go to the trouble of saying that? Ah, there's a scale. Well, if 1 centimetre is a kilometre and there's 13 of these centimetres, then Jim's house is 13 kilometres away from the school. Well, I better not walk, I better take my bike. Oh wait, he said 1 millimetre is equal to 1 kilometre. Ah, well I happen to know that there are 10 millimetres in 1 centimetre. So if 1 millimetre is 1 kilometre, then one of these 1 centimetre squares is 10 kilometres. And if there's 13 of them, then Jim's house is 130 kilometres away from the school. Forget the bike, I'm taking the train. Okay, so I've got myself a map, and it's a map of the United Kingdom, and I've got a scale here that says 50 miles, and I've got two locations marked. I've got Land's End and the Isles of Scilly, and I want to know how far is it from Land's End to the Isles of Scilly. Well, my scale says 50 miles. Now, if this was on paper, what I'd do is I would measure the distance that has been shown to be 50 miles, and I would measure that distance, and I would make a note of however many units that is, maybe centimetres or inches or whatever, and then I would measure the distance that I'm interested in. That's the distance between Land's End and the Isles of Scilly, and then I would divide that distance by this distance that I'd measured and written down, and then I'd multiply the result by 50 to get the actual real life distance. Well, I can't work with a ruler, I'm going to have to work with pixels. In the bottom of my screen, it's actually putting Land's End at 312 pixels along the x-axis. And the y-axis is not changing by enough to make any significant difference. And so this then goes to 287, 288. Let's say 288. So where's Land's End again? 312 to 288. So if I subtract 288 from 312, 312 minus 288. Well, I can borrow 1 from that column. From 12 is 4. Borrow 1 again. Oh, that should be 10, because I borrowed 1 from that, so that's 10. So that's 2, so that's 24. So I make it approximately 24 pixels. Between Land's End and the Isles of Scilly. Now, how many pixels are in 50 miles? This is going from, let's say, 357, 358, I'm not sure. 35, let's say 357. That's 357 pixels to where's that? That's too far. So 310 pixels, 310 pixels. Okay, so that's 47 pixels is equal to 50 miles. Brilliant. Okay, if that was 50 pixels, then 1 pixel would be 1 mile, and I would say that that's 24 miles, because that makes life easy. This is not quite so easy. So it's actually 24 over 47 times 50. Which, for that, I'm going to need a calculator. Okay, so I've got my calculator. So this is just 24 divided by 47 times 50 is 25.5 miles. So that's, I'm going to say 26 miles approximately. I'm not sure how far it is in reality. These kind of maps are actually notoriously unreliable because the Earth is round, so you can't actually get distances exactly right. If the distances are right down here, they'll be way off up here because of the curvature of the Earth. But it's not bad as a sort of estimate. I wouldn't put too much stock in it, but as an estimate, it's not too bad. In fact, in the days before GPS, we used to rely on these. Okay, so I'll make that approximately 26 miles. Okay, I hope that was helpful. I'd like to wish you all the best with your revision and all the best with your exams. And don't forget to like, comment and subscribe, and I look forward to seeing you in another video.